Hi folks, Dr. P here. In this question, this is question 3 from the probability assignment. In this question here we have packet 1 containing an orange candy. We're going to represent the orange candies with the letter O. A lemon candy, which is going to be represented by letter L. And a strawberry candy, which is represented by letter S. In packet 2, we have an orange candy, a strawberry candy, and a raspberry candy, which is going to be represented by letter R. Without looking at the packets, a student takes one candy from packet 1, then one candy from packet 2. In A, draw a tree diagram to show all the outcomes for this experiment. So we have the two packets. We have packet 1, and then we have packet 2. And then we can also have a third column here that will list the outcomes. The last column is not necessary, but it might make it easier to see the outcomes when we're done here. So first we pick candy from packet 1. There are 3 different colors, or 3 different flavors of candy in packet 1. There is the orange candy, there is the lemon candy, and there is the strawberry candy. And because this is a tree diagram, I'm going to connect these with these lines. And what this represents is that as we're taking a candy from packet 1, we have these 3 different options. We're going to choose one of them. In packet 2, we have also 3 different candies, but this time they are orange, strawberry, and raspberry R. So here what we're going to do is we're going to connect these 3 options in packet 2 with this first option in packet 1. What does this mean? It means that if you pick an orange candy in packet 1, then for packet 2 you have 3 options. You can pick orange, strawberry, or raspberry. And so we have these 3 options for all. It doesn't matter which ones of these we choose in packet 1. So that means we're going to repeat this. We're going to write orange, strawberry, raspberry. We also have these 3 options if we're picking a lemon in packet 1. And we also have these 3 different options if we pick a strawberry in packet 1. So here's our completed tree diagram. And now let's identify the outcomes. So the outcomes are going to be the 2 candies that we get from packet 1 and packet 2. So the first outcome here is going to be O and O, orange, orange. We get orange candies from both of the packets. The second one, now we just follow the branches in this tree. So the second one is orange and strawberry. The third one is orange and raspberry. The next one is lemon and orange, lemon and strawberry, lemon and raspberry. And finally we have strawberry and orange, strawberry and strawberry, and strawberry and raspberry. So these are the 9 different outcomes that we have here. So that's question A. In question B, they want us to list the events that both candies are the same type as a subset of sample space. So this is going to be a set, so we're going to use set notation. So we use these curly brackets, and within those curly brackets we're going to list the elements of this set. So the set we're looking for here is that both candies are the same type. And we have we have this outcome here. Both of them are orange. We go through our outcomes, and then we have the second one here. Both of them are strawberry. So we're going to list them as OO, and SS. Right? In the question C, list the event a strawberry candy is not chosen as a subset of the sample space. Okay, so we're looking at a strawberry candy is not chosen. We're going to be using the same notation as in B. We're going to be listing this as elements in a set. Okay. Use a different color here. So a strawberry candy is not chosen. Well, we're going to use green here. So the first option, clearly a strawberry was not chosen. The second one doesn't apply because we did choose a strawberry. There we did not choose a strawberry. No strawberry. No strawberry. And then in the last here, we have strawberries in all of them. So we're dealing with these 4 outcomes here. So we're going to list them as OO, OR, LO, and LR. In D, state the probability of the following events. Both candies are the same. So remember, for probability, we are using the following formula. Is going to be the number of favorable events, I'm going to represent that by F, divided by the total number of events, which is T, or the total number of outcomes. Here we have a total of 9 outcomes. So to determine the probability that both candies are the same, candies are the same, the number of favorable outcomes here, well, we have the first one here, OO, then we have the 2 strawberries. So there are 2 favorable outcomes out of a total of 9. And we can leave it as a fraction here. They're not specifying in what format they want the probability. We can also divide the numbers. If we leave it as a fraction, don't forget you have to reduce this fraction. This one is already in its simplest form, so we're done here. Okay. In second question here, probability of a strawberry candy is not chosen. So not strawberry. Well, how many favorable events do we have? We have 1, 2, 3, 4, and we still have 9 total events. So 4 over 9. In 3, at least 1 orange candy is chosen. So probability at least. Well, so we can write it in words. Just to keep it simple, at least 1 orange. So at least means 1 or more. So we have 2 orange candies here, so that counts. So there's 1, 2, 3, 4, 5 outcomes. So it's going to be 5 divided by 9. Right? And then finally here we have the probability that the candies are of different flavors. So let's count the number of favorable events. So not the first one. This one counts 1, 2, 3, 4, 5, 6, 7. So 7 over 9. Okay. Now there's one more question here. Explain the relationship between the answers in part 1 and 4. So we're looking at the answer to this question, the probability that both candies are the same, and the answer to the following question, the probability that the candies are of different flavor. So these 2 events are complementary events, so they're each other's opposite event, or each other's opposite. And one way we can actually see that is that if we add up the probabilities of the candies being the same and the probability of the candies being different, we would get 1. Okay, so probability same candies, we can just write same, plus probability different has to equal to 1 because they're complementary events. And if we do that math, the probability that they're the same is 2 over 9, plus the probability of them being different is 7 over 9. This is equal to 9 over 9, which is equal to 1. I hope that helps. Until next time, may the math be with you.